Vaishnavi. Today I'm presenting my project, a custom Spring Boot starter for multi-tenant data source routing. This project demonstrates how to build a scalable and secure SaaS infrastructure using a database per tenant strategy. The goal of this task was to create a modular, reusable Spring Boot starter that automatically handles data source routing instead of writing tenant switching logic inside your business applications. You can simply include the starter and it handles the complex database routing behind the scenes. This is the test context. Now, this is the multi-tenant auto configuration of the Java. The tech stack used here in this project is Java 17 and Spring Boot 3.3. It is used for the core framework and Spring Data JPM or Hibernate for database abstraction. PostgreSQL used as the multi-database engine and the Docker and Docker Compose for containerization and automated infrastructure setup. And here Maven is used to manage the multi-model project structure and we also use a Spring Boot Agitator for monitoring the health of all the tenant database. All the database. Here is the README. Mm, Uh, in SaaS environment, data isolation is critical. If you store all the customers in one table, a single coding error could leak sensitive data to another customer in one table. A single code error could leak sensitive data to another customer. This project. Mainly, this project is multi-tenant is used for creating one data and many tenants at a time. With one tenant and multiple users, and these users can't be isolated. They can't see the others' data. They can't see the others' data, and this project solves security risks, boilerplate code, deployment complexity, and imagine a platform like Sophia or Slack. Each online store or workshop requires its own isolated database for security and the customer backup strategies. This strategy provides an architecture foundation for such platforms. It means by using the online stores, there are multiple tenants and users can have only their access. They cannot have the others account or ID to access. This is the high level flow architecture. It refers to the Marmot diagrams in the Marmot diagrams. Here, whenever Marmot graphy, it goes to the sub-external and client and the end. Here there are many subgraphs. If the client send the HTTP header interceptor and interceptor store the ID and the context, then the API to repository and report to router and router look up for the ID and context and it routes the query one by one and the life cycle and the routing flow, client and inceptor as a tenant inceptor, context as a tenant constant, and later app as a service, and router as the tenant our routing data source, and database as the tenant data source. And I choose this database per tenant approach over shade schema because it offers pure isolation and it has a last tenants don't slow it down once and the project structure of this task. Mm. And now I'll show you how to implement this task. I have already noted the commands in the notepad. First, to set up the environment, to set up the to set up the environment. And now we are building up the Docker for building starting the services. Let us checking the status of the Docker. Here it is building. In my previous project, there is already used this port, so there is an error. Now I have stopped that task and rebuilt this task, and it is success now. And here is to check the overall health of the task. Sorry, I have forgotten. It should be, it is a bash command. So that I, this is the overall health. Now it is used to create the tenants. Here the status is up, and this project is used to create the tenants and also the tenant IDs and show retrieve users from each tenant. We have many tenants and multiple users, and only separate user can access one tenant. Here I am creating a tenant one with name LC Green. Here ID is equal to 3, name is created, it is executed and created. Now I want to create another tenant, and the second one is also with ID2 and name Bob Blue is also executed and created. And to verify data isolations, that means to retrieve users from each tenant, we use these commands. It means using these commands fetch only tenant one user. It means here tenant one user is Alice, so it should only show the Alice. So it is only showing the tenant name, tenant one user, tenant ID, and the ID 3 and name is Alice Green and its email. We even have two tenants or bill before, but it is showing only about Alice. Whenever we go for the tenant 3, it only shows the tenant 2 ID. No, I am giving the tenant 2 for the tenant 2 command. It only shows the Bob Blue and the name of the Bob Blue and the ID of the Bob Blue. Now it also shows the now it shows the also the email. Now I'm giving the tenant 3 which is doesn't exist. Let's see the output for it. Here fetching tenant 3 users. There is no tenant 3 is created. Tenant 3 is created already, so it fetches the tenant 3 users and gives an empty one. It means there is no previous tenant 3 created. If we created any tenant 3, it will show you the users. And so to check the error handling, verifying the customer starter handles invalid request gracefully. If any missing tenant header, it should show for or not 400. Yeah, as expected, it is showing the 400 uh, and the connection is closed. Error is bad request. Message extended header is missing. Here we didn't get the header. So, and now we are giving an unknown or invalid tenant where previously we given the tenant ID Three, it is not, it is unknown. So now we are giving the invalid tenant ID. It is also shows 404 not found and the error is not found. Here we have bad request for 400 for giving the missing tenant header, and for invalid tenant it is showing 404 and the error is not found. Um, and to stop down this, to take down this, we use Docker Compose down. It means it removes the volumes and the containers in the Docker. And this concludes my presentation. This code is modular, well tested with integration test and ready for expansion into a production level SaaS platform. Thank you.